Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem of quantum mechanics. Problem having been chosen from the book Quantum Mechanics Concepts and Applications. Author is Nordine Zetley. Okay. As usual, we first come to its statement. Okay, a 45 kilowatt, kilo standing for 1000, so we can say that a 45,000 watt broadcasting antenna emits radio waves at a frequency of 4 megahertz. Mega stands for 10 raised to the power 6, while hertz is a unit which is equivalent to 1 over second, that is second inverse. Okay, units of hertz are second inverse or 1 over second. Okay, a 45,000 watt broadcasting antenna emits radio waves at a frequency of 4 megahertz. How many photons are emitted per second? Part B. Is the quantum nature of the electromagnetic radiation important in analyzing the radiation emitted from this antenna? Okay. Part B is quite same as we discussed in previous video. Okay, a similar situation was given in that problem. Okay, now we come towards its solution. Okay, solution, first we come towards part A of the solution. We know that 1 watt is equal to 1 joule per second. Okay, this is by definition of watt. Okay, at the end of this here a small screenshot has also been shown. Okay, in which two tables are shown. Okay, one table is of physical constants and the other table is in which some information about power is given. Okay, 1 watt is equal to 1 joule per second, 1 horsepower is equal to 746 watt equal to 550 feet pound per second, and 1 BTU per H hour per hour is equal to 0.293 watt. Okay, we first come to part A. Okay, we know that 1 watt is equal to 1 joule per second. This implies that when 1 watt is equal to this, then so many watt will be equal to this. Okay, so when 1 watt is equal to 1 joule per second, so quite clearly 45,000 watt will be equal to 45,000 joule per second. This implies that energy is equal to 45,000 joule. Okay, here energy is in joule and it is per second. Okay, within bracket it is explained that is E equal to 45,000 joule is the electromagnetic energy emitted by the antenna in 1 second. Okay, now we move forward according to Planck's postulate. Okay, Planck's postulate or Planck's hypothesis. According to Planck's postulate, the energy of an oscillator of natural frequency nu must be an integral multiple of h nu. What is h? H is Planck's constant. Okay, according to Planck's postulate, the energy of an oscillator of natural frequency nu must be an integral multiple of h nu, that is E equal to n h nu, where n is equal to 0, 1, 2, 3 and so on. We designate this equation as equation number 1. Okay, here n is an integer. Okay, and when some value multiplies with an integer, we call that multiplication as integral multiple. Okay, where h is a universal constant. Okay, in other words, h is a Planck's constant, and its value is given in the table at the end of this problem. Okay, here Planck's constant value h is given, h equal to 6.626 into 10 raised to the power minus 34 joule second, and this is alternatively equal to 4.136 into 10 raised to the power minus 15 electron volt second. Okay, now according to, yes, where h is a universal constant, in other words a Planck's constant, and h nu is the energy of a quantum of radiation. Okay, we have studied quantization in enough detail in lower classes. Quantization means, dear students, the term quantum is actually somewhat contrary to the term continuum. Okay, the term continuum may be interpreted as having any value. For example, 1, 2, 3, similarly 1.25, 1.72, 1.92, but quantum indicates that it is a discrete, that is, it can either be 0 or it can either be 1 or 2 or 3, it cannot be 1.5, it cannot be 1.25. Okay, integral multiple means discrete, that is appearing as whole numbers. Okay, not in fractions. Okay, using the values of E, H and nu in equation number 1 we get. Okay, the students value of E, we have noticed that it is equal to 45,000 joule. Similarly, H is Planck's constant and its value is given in the table at the end of this problem, and value of nu, that is frequency, is also given in the statement, which is 4 megahertz. Mega standing for 10 raised to the power 6 and hertz mean 1 over second. Okay, so when we will put these three values in equation number 1, we will get 45,000 joule is equal to n into 6.626 into 10 raised to the power minus 34 joule second into 4 into 10 raised to the power 6 hertz. Okay, this is the value of nu, 4 megahertz. This is the value of Planck's constant H, and this is the value of E. Okay, next only simplification, nothing else. This implies that 45,000 joule is equal to n into 26.504 into 10 raised to minus 28 joule second into hertz. What we have done, we have multiplied this value 6.626 with 4, and hence we have got this value. Okay, in the next step, dear students, you are seeing, we are seeing that joule is also on left hand side and joule is also on right hand side. Okay, so this joule will be cancelled with joule. Either we shift 1 joule on other side of equality, or we divide both sides by joule, so joule will be eliminated. Okay, next hertz has units 1 over second. Okay, so second will be cancelled with 1 over second or second inverse. Okay, so joule is also eliminated and second is also eliminated, and we will get only 45,000 equal to n into 26.506 into 10 raised to the power minus 28. Because, dear students, this is 10 raised to minus 34 and this is 10 raised to the power plus 6. So from 34 it will remain minus 28. Okay, so this implies that n becomes equal to this over this and this over this and this over this, and n finally becomes equal to 1.6977 into 10 raised to the power 31, and this is equivalent to, or this is approximately equal to, or this is equal to, okay, we are not here bound to use the symbol approximately equal to. Okay, we can put it as exactly equal to. Okay, it is our discretion. Here 6 will be rounded as 7. Okay, because next figure is greater than 5 and next figure is also greater than 5 and next figure is also greater than half, that is 5. Okay, so n becomes equal to this and it will have no units because n is just a number. Now part B, its answer is that no, the quantum nature of the electromagnetic radiation is not important in analyzing the radiation emitted from this antenna, because the antenna emits a very large number of photons per second, that is 1.7 into 10 raised to the power 31 photons. Okay, hence this type of radiation can be adequately handled by classical theory of electromagnetism. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.